Everybody, I'm Guy, and I'll talk about Zero Trust. I'll start the talk looking at traditional approach to securing applications on-prem. Then I'll talk a little bit about the impact of cloud on trust and security, and how applications need to adopt to operate securely in a Zero Trust environment. And I will then describe our approach to implementing Zero Trust. Just before we start, for those who are not familiar yet with HashiCorp, we operate in a few areas in cloud infrastructure and automation. Our portfolio addresses the provisioning, securing, connecting, and running use cases for managing applications in a multi-cloud environment. And today we're focusing on the securing part, that is Vault, console, and boundary. All right, so I'll start by looking at how data centers have been traditionally secured and talk about some of the challenges there. Right, so it was easy, or rather sufficient, to secure the data center at the edges because we believed we could identify and classify bad actors in a very clear way. Inside the data center or on the network, good. Outside the data center, bad. Right, and with this model, the entire focus is on controlling the ingress, the entry point into the data center. And that is done with firewall or with a web application filter, C middleware or sorts, whatever it is. And then sometimes we'd also deploy additional perimeter networks with reduced functionality to host user-facing apps. Right? Sometimes we'd have near DMZ and far DMZ. And all that is done basically to keep bad actors away from the core network and our private data centers. And we could do that because we had full control over the physical stack, right? Even the building and the walls, the network gear, infrastructure, and connectivity all the way up to the entry into the data center. And so that way of working over the years also led application teams to expect security and get used to security being done by someone else, right? It's kind of someone else's problem. There's a different team that runs in parallel to the application team, and they will secure the environment. And then if we even take it further, when application teams went through cyber reviews or security tests, owners could then look at findings and quote unquote accept the risk to avoid delays, then almost think about it like a technical debt, right? And that was all okay, because we fundamentally accepted that securing the perimeter was sufficient. Once the perimeter is secure, the data center is secure, the network can be trusted. And with that model, it was okay for applications and infrastructure to be less strict about security. Right, and then came cloud and basically flipped this model on its head. And let's see why. There are many things that need to evolve when we think about cloud computing, but in the context of Zero Trust, I want to call out a few main points, right? The first and main point is that with cloud, and more so when operating with multiple cloud providers, the network is a logical construct, right? It's not a physical network that we control. We don't have our own gear. Network spans multiple environments, multiple providers, and we create a logical virtual network with connectivity between the cloud bubbles, right? And then if we overlay cloud adoption onto how the network is set up, we'll have some core applications that remain on-prem. We have applications that are migrated to the cloud, and then typically net new applications are just deployed on the cloud from day one. So now we have a requirement for connectivity and access from the public domain, an environment that we traditionally regard as low or zero trust, with our very own highly trust network and data center. Right, so that's kind of the first change that is happening. The second is this move to focusing on speed, agility, self-service, and the developer experience. Traditionally, cyber teams being a gatekeeper at the end of the process, now kind of moving out of the way, right? Cyber teams define policies, define requirements, and move out of the way for application teams to implement and comply with. So we're now in a situation that cyber are not controlling every change along the way, and we need a different way to enable and ensure the safety and security of applications and data in an unsafe environment, right? And lastly, the very fundamental assumption that we operated with, which is attackers are outside of the network and everybody on the network has good intentions, can no longer hold, right? Because regardless of the location of actors, they would be on public network or private network. We cannot assume intent or whether an actor has access to other areas. And this is something that needs to be kept on checking. Right? So kind of moving on, we need to think about how we change security, right? How do we adapt to this new reality? And I'm talking about a few different things. The very first thing is really to change the control point. Changing from using IP addresses and network identity to using some different form of logical identity, right? And that is because different providers will have overlapping network addresses, they will override IPs, technology stacks will hide IP addresses and change them dynamically. So think NAT and Kubernetes and whatever else platforms you may be using, right? So we need to move away from IP addresses as a form of identity, something else that we can assign to services, right? So it will be a logical identity at a higher level than the network. And every dialogue between two endpoints needs to start with authentication and authorization to establish this identity. The next thing that we need to look at is how we manage secrets, right? So consider the starting point where you have hard-coded username and passwords in source file or in config file, which are, very easy to leak, very easy to get compromised. And then think of the far end of the maturity curve where you use on-demand ephemeral secrets and identity, right? So in the same way that workloads are ephemeral, so should identities be, and so should secrets be, right? So imagine a nirvana state where credentials, let's say an API key is used one-off, right? So if an API key is compromised, it's completely useless after it's been used once. And lastly, we want to elevate the data encryption and data protection to the application layer. And the traditional approach is where we'd use some sort of a transparent disk encrypt, right? It's designed to protect against physical access to the disk. But then if we consider an attacker on the network, not physically in the data center, but on the network, and they have access to the application or to the database, then the transparent disk encrypt will happily transparent decrypt the data, right? So we need to change how encryption and data is managed, and elevating to the application level means that the application will store and read encrypted data so that if there's a data breach, the data is completely meaningless in the database on the file system. And then application would use a different form to decrypt data and keep it decrypted in memory. All right, so these are the main 3 points when we think of how to adopt to the new reality. All right, so we talked about the traditional ways, what's changed and how to adapt. And in the next section, I'm going to cover our approach to implementing zero trust, and that is with Vault, Console, and Boundary. So we break the problem into 4 different areas with an overarching guiding principle that we transition from the IP-based control to identity-based control. And we implement machine-to-machine differently to human-to-machine. So the requirements at the high level are quite the same, similar. But when we get into the detail, you'll see that the implementation is different and we need different tools to deal with the different situations, right? So I'm now going to cover each of these boxes and talk about the technology we use to implement it. I'll start with machine-to-machine authentication and authorization. This is where we use Vault. And Vault really solves 3 main use cases, 3 main problems. The first is secret management. So think of Vault as a central wallet for static and dynamic secrets. And with secrets, you can think about identities as well, right? So Vault will be managing and brokering identities and secrets between different environments. The second and the third use cases actually are about data encryption and protection. Right, so we talked about earlier about the need to elevate encryption from being done transparently by the infrastructure to being done at the application level. This is where applications would work with Vault to encrypt and decrypt data as they read and write from persistent store. And the last part is to help secure connectivity between application and using Vault for credentials, for certificates, sorry. So Vault, in the context of Zero Trust, the guiding principle for Vault here is brokering identities. Right, we use Vault to centrally manage secrets and broker identities. It will dynamically interact with other environments and other venues, and it will hide all the complexity of moving identities and secrets between different realms. Right, so typically an application flow would start with authenticating against Vault. Vault will delegate to an authentication provider. Vault will apply policy-based enforcement to decide whether the client is allowed to access and read the data that it is requesting. And then it will, at the back end, interact with the edges to enable the brokering. Right, so now we have an established identity. We know who we are dealing with, and we need to move on and secure the access between the different endpoints. And this is where we use Consul. Consul is our service networking solution. It is used to automate network workflows in a secure way across any technology and any environment. Vault 2 solves three main network problems. You can think about them as a maturity curve as well. Right, the first is a holistic service discovery with a health view. So Consul will hold a registry with up-to-date location and health status of deployed services, and then it exposes a DNS view, and sometimes used as a way to automate updates into a CMDB system. The next use case is the service mesh. With service mesh, the security and the networking direction functions are decentralized, and Consul enforces policy-based access, and connectivity is secured using mutual TLS for intra and inter-cloud access. And the third use case is the network infrastructure automation, or in short, NIA. In this use case, Consul integrates with existing network infrastructure solutions, either directly through plugins or indirectly through Terraform, to implement seamless updates to the network. This is a really, let's do an example. This is a really game changer to how network is managed, right? So imagine a steady state, what we call day two. Now an event occurs and the environment needs to change. Various events can happen. It could be proactive or reactive. Let's say we have a scale-up event. And then to implement the scale-up, Consul, through Terraform, will provision bottom-up the full required infrastructure, including the compute, the network, the storage, and so on. And will actually then instruct the firewall and load balancer to include the new infrastructure in the secure environment. So that's really zero trust, zero touch, really, real game changer to how network is managed in a safe environment. So that's Consul. Let's summarize. It's the solution for securing machine-to-machine access, moving away from IP-based networking to identity-based networking or application-based networking, and automating network infrastructure. The guiding principle here is decentralizing the network and promoting the network management to the application layer, logically speaking. Right? Think about it as top-down decision-making for network updates. All right. So next we'll talk about the human-to-machine side of zero trust, right? As with machine-to-machine, we want to separate and deal with the authentication and authorization, and then separately the access requirement. We'll start with authentication and authorization. So human authentication has evolved over years, right? There was a move to more centralized identity management and the use of single sign-on. Usually a user journey starts with authentication against an LDAP or an Active Directory or Kerberos or whatever else. And then the identity is sent on via a single sign-on platform like Okta or Ping, etc., to the target venue. In a way, there's not much new here with regards to cloud. It's the same model that we used on-prem, but just now extended to external systems. And then last but not least, we need to talk about the human-to-machine access. Right, and this is unlike machine-to-machine, this is typically a break glass scenario or an infrastructure maintenance workflow where a human needs to access the environment. For human-to-machine access, we use Boundary. It presents a modern way to automate and protect application, infrastructure, and endpoints. The new product, it's available as open source currently. And let's look into how Boundary works. Right. So before we start, here too, I want to look at the traditional approach to implementing user access, human access. And I want to call out some of the challenges that this approach includes, right? So in this example, I would have a human accessing some sort of resource on the network. So the first thing that we need to do is to connect via VPN. And for that, we need to have some sort of physical key or an RSA or biometric key or something else that needs to be distributed safely for onboarding and more so collected securely for offboarding. Right? So this is a slow, heavy, costly, and risky process. So then after we have moved from the VPN, the user now is inside the corporate network, right, so to speak, which is fine because we want to be on the network to access a resource, but it's also not very fine in a zero trust environment, right? So we now have a user with access to anything potentially on the network, right? The next part is to go over the security layer that protects our resources. And if anything is implemented, it's typically going to be an IP-based firewall or other IP-based control. And then the challenge here is that when IPs change, and that could be due to a failure or a maintenance or a scaling of an application, there needs to be an update to those IP-based control, typically a ticket-based, slow-moving change from network ops, right? So it's a little bit brittle. And then lastly, the user needs to have access to the resource, needs to have some sort of credentials and username and password that they keep, or if they use a shared username and password, then basically audit and governance are completely out of the window, but they need to be known at the resource layer. So then when we thought about the human-to-machine access in a zero trust world and looked at the workflow that we described, we kind of realized that it is limited. The process was built for high trust and slow moving environments, right? These are most of the limits that we described. So we need to rethink a more modern, dynamic, low friction solution that will also improve the security posture overall, right? And this is how Boundary solves this use case. So here a user would log in to a single sign-on, the same single sign-on that exists. No special onboarding or offboarding is required. No additional processes are needed. I just authenticate and authorize against an existing single sign-on. Then the user is presented with a list of resources to which they have access. And this is role-based, it's identity-based, and it is updated dynamically as the environment changes. So think about a feed from Kubernetes or a feed from Terraform that keeps updates as the reality changes, right? You don't need to change the list, just adapted to the new physical. And then at this point, Boundary will create a secure session between the user and the resource. Think about it, logically speaking, as an SSH channel. There's no access to the network. The only thing that the user can do is access that resource. The network is safe. And even if this connection is compromised, there's no access to other network devices, other servers, other areas in the network. Right, and the last part is that we need to allow access to the actual resource. And this is where Boundary, with help from Vault, will broker the identity and create credentials dynamically to allow for the access. So the user doesn't need to be known at the resource, doesn't need to hold any username and password to be able to access the database, for example. Right, and then at the end of the session, this whole thing collapses, credentials are removed, the session is destroyed, and there's no remaining opportunity for unauthorized access or behavior. So kind of the workflow from Boundary's perspective, a user authenticates against existing authentication provider, and then authorizes with a single sign-on. And then from there, Boundary would create a direct access link and ask Vault for help with the identity creation and dynamic credentials creation for that session. Right, so to summarize, to implement Zero Trust, we want to move away from IP-driven controls to identity-driven controls. And that is the single most important thing that I want you to take away from this talk, right? Moving from IP and physical to identity and logical. And we do it by breaking the problem into 4 different areas. The first part is authentication and authorization. The second part is securing the access. And we do it separately or differently, slightly differently to machine and human to machine. Right? We can look holistically and use look holistically at this problem and use Vault, Console, Boundary together with the SSO infrastructure to implement the full scope of Zero Trust. And that is all for me. And next, I'll hand over to Sarah to talk about her experiences at ABN AMRO. Over to you, Sarah.
Thanks, Guy. Sarah, before you start, I just wanted to launch a few polls. As you guys know, or may know, we are announcing HCP Vault GA today. So we wanted to just add in some polls to check what your current appetite is for a cloud-based secrets management platform such as that. So I just wanted to add in, I'll launch the 2 polls, and then Sarah, feel free to go into your talk. Sarah, we're having, I don't know if you've gone into it yet, but we cannot hear you yet.
I'm just trying to get everything set up over here.
No worries.
Sorry. I'm
okay, so, perfect. There you go.
There we are. Let's see.
Okay, I'll give about 10 more seconds and then I'll close the polls and you can get into it, Sarah.
Sure.
Okay. All right, I'm going to end them now. All right. Okay, Sarah, you're all set.
All right, sounds good. I'll start sharing my screen. Hopefully. There we go. Can you guys see everything okay?
Yep, we're seeing it now.
Awesome. Yeah, so I'm here today to talk a little bit about Vault and the implementation of Vault. And generally speaking, centralized secrets management, but within that really highly regulated environment. And then we decided we would take it one level further, and we're going to try to do this within a highly regulated environment, but we're going to do it DevOps style. Just a little background information. My name is Sarah. I'm the secrets management architect at ABN AMRO. So it's really my job to implement this secrets management program and build that out across the bank. I hold a master's in engineering in cybersecurity from the George Washington University. And my background is actually, I started in software development. So for me, it's really important that whatever we do, it's easily consumable by the development teams. And it's not going to hinder their development, but it will speed them up a little bit. For those of you not familiar with ABN AMRO, we are the third largest consumer bank in the Netherlands. And currently we're looking at about 2,600 different applications, and those are spread across 19 different countries, all of which have somewhat different regulations that we have to be able to comply with. So I'm going to take it back to what Guy was saying a little bit. When we started just with general infrastructure and legacy infrastructure within the bank, we were really looking at this kind of like castle and moat scenario. We had this very pretty castle with a fortress around it. We knew that anything that wanted to kind of get into the castle would need to go through some sort of barrier first. And that meant that we could kind of trust everything that was within inside the walls of this castle. It wasn't necessarily exposed to the internet, and if it was exposed to the internet, we could really isolate that portion. And that was fine for us. That gave us everything that we needed to do. And we didn't really see any inherent security problems with that. But then as things evolved, as things always do, we ended up with the cloud. And the cloud by default is obviously connected to the internet. It opens up attack vectors. And then we decided to further complicate that and deal with the multi-cloud. And so now we're running things on-prem on different clouds, and we have to kind of decide how are we going to pass information between these scenarios? Are we going to pass information? And if we do that, then, you know, what are the dangers and how are we going to do that in a secure manner? Are we going to encrypt everything via SSL? Is that sufficient? And if one thing has to authenticate, yeah, where does that leave us in terms of the ability to do that when one cloud's identity might not be known by the other cloud, or on premise might even say create its own identity? So we need to come up with a way that we can kind of make all of these things talk securely while fulfilling all of these regulations. Okay, that's complicated, obviously. But then because that wasn't complicated enough, we decided to take it one step further. And we started running containers, Kubernetes, Nomad. And we end up with these constantly evolving identities that are on different platforms who aren't necessarily known to each other. And yet we still have to be able to recognize those identities enough to authenticate and provide the necessary data. You get where I'm going with this. It's not simple. It's constantly evolving. And yet somehow, through all of the regulations, through all of the sensitive data, through all of the PII, we need to be able to serve this up securely. And so that's kind of where we decided as a bank that we needed to make sure that we had this under control, because ultimately the secrets are what is securing quite a lot of our data. And if we aren't dealing with this in a fashion that's extremely controlled and known to us, we're going to have issues with, potentially leaked credentials or leaked data. The regulators, obviously, they can say that we aren't protecting our assets sufficiently. So yeah, we decided to then go ahead and look at this comprehensive secrets management. So to make sure that we're all kind of talking about the same thing, when I say comprehensive secrets management, I really mean the entire life cycle that is involved with authenticating and authorizing these workloads. In our case, we're really looking specifically at machine-to-machine workloads. But we have a lot of criteria for dealing with this. The initiation needs to come from this identity-based trust. We need to make sure that we're really, each request is being authenticated, that wherever possible, we're enforcing this principle of least privilege, because what my workload may be able to consume is not necessarily what any human should be able to consume. As an administrator of the vault, I shouldn't necessarily be able to read the secrets, but there may be operations that I need to do as an administrator that, my container doesn't need to do, because all that container needs to do is read. Also enforcing role-based access, making sure that only the necessary people who do need to get into Vault, those administrators, or if a team needs to place a secret because it's a static secret, we need to make sure that those things are only happening within a specific context. The rotation of secrets, for us, the regulators have set out that all secrets must be rotated every X number of days. So we need to make sure that that happens, and that those keys and certificates and everything else are constantly being rotated within that delay. Now, obviously, if we're using those dynamic secrets and those dynamic secrets engines, that saves us a lot of work. But in the case where that's not possible, how are we going to do that? And, where does that responsibility lie? Does the team need to trigger that? Do we need to be pulling some logs? It's really just a question of how are you going to implement that? And then obviously a really large part of DevOps and secure DevOps at that is making sure that we have a proper audit trail, that we know that there have been attempted connections, but also we want to know the unsuccessful connections, because sometimes that's going to tell us a little bit more than, the happy flow, the person who can authenticate and should be able to authenticate. But then, because it is DevOps and because we are dealing with 2,600 applications, we want to be sure that we can do this in an automated way. And really the reason behind all of this, and the reason that we want to be able to do all of this, ultimately is to protect our assets. And yes, assets in terms of your financial assets, but also data, personally identifiable information, bank account numbers, anything that could be considered potentially insider trading information. All of these things need to be secured, and need to be protected. But what is also frequently overlooked is that reputation. You can't really put a value on what your reputation is. However, if you lose that reputation, coming back from that can be really difficult. So, if by increasing our positioning in terms of secrets management, we can protect our reputation a little bit, then yeah, we're definitely going to do that. Also to support risk management, compliance. They know that they have a team that's in control of secrets. that these are being done in a way that's been approved across the bank, and that there's not just secrets stored randomly in repos or hard-coded into config files. We know where all of these are, and things like PCI DSS and SOX, they both have contingencies that you must know where your users are coming from. Now, users in the case of PCI DSS is explicitly people. However, if you have people patching into containers to manipulate them in some way, does that then kind of blur that line between user being a machine, or does it still rest as a person? Well, if you're using Vault, you know, and you can audit all of it, whether it's a person, whether it's a machine, you know all of the connections, all of the requests for credentials. Same with SOX. They want an audit trail. They want to know that you have everything there should you ever need to go back and look at what was accessed when. We also want to minimize the secret sprawl. The more multi-cloud you get, the more involved you get in connections, APIs, databases you have, the more likely you are to end up with secrets that just kind of leak everywhere. So by coming up with a comprehensive secrets management program, we can then bring them a little bit more to center, and we can make sure that they're in control, that only the people have only the things that need the secrets can access them. If we revoke them, we know that our neighbor down the hall isn't going to necessarily start screaming. But yeah, we want to really mitigate that decentralized management. We also want to eliminate the hard-coded secrets, obviously. I think even last year, the year before, GitHub and AWS both came out publicly and said, start scrubbing your repos. I also think GitHub has either released or was about to release an alerting system that would let developers know if a secret was committed. So this is a widespread problem. It's not something that's just limited to our ecosystem or potentially your ecosystem. It's something that's quite widely spread, and it's something that I've seen in other industries as well. And then we also want to secure and automate the certificate distribution for ephemeral workloads. The shorter lived these certificates are, the better off. Once a certificate is compromised, especially in an ephemeral workload, you don't want it there for 2 years. But also, if you're constantly spinning up containers, if you're constantly spinning up clusters, you don't want to have to deal with manual insertion of certificates with each deployment. So we're really starting focused with containerized solution, because that's where we feel that we can get the most sort of bang for our buck. But we're also starting to look at, how can we adapt this throughout the enterprise, and start looking a little bit more towards the non-containerized VMs as well. But looking at Vault, and knowing that Vault is really great at this, machine-to-machine authentication, there are things that I became aware of as I worked with Vault, and also as I trained people to also use Vault. So one of those things is policies and your ACL policies. I think there's something that can be quite overlooked. It can be really easy to implement Vault and say, hey, here's root, or hey, let's just throw in an admin, and we'll call it a day and it's secure. Well, the thing is, that's not necessarily the case, because we are looking at so many attack vectors. If my container has too many permissions, it then can also elevate, and can potentially do a decent amount of damage should you have a breach on that container. So the scenario here is that you have an app and it just needs to read database credentials. but yeah, just to be sure, you're going to give it, let's give it a few more permissions, right? So like, we'll just say we're going to give it create, update, read, and list. And because we're trying to roll this out throughout the company, we're just going to give it the path secret with wildcard. So, okay, I can't delete anything. So that seems kind of okay. My container needs to be able to read it, or my application needs to be able to read it. So that should be fine. List, yeah, it just gives me a little bit of information about where my paths are. But the real problem here comes with create and update. So because I'm giving it extra permissions, what I can actually do with this specific example is I can actually destroy a secret. And if I destroy a secret, then I'm going to have to go back and I'm going to actually have to do a restore in order to get that secret back. So in this case, yeah, what I would say is there are kind of two issues. And to rectify that, what I would say is be a lot more explicit with your path. So really like pin that down. And one of the ways you could also go about this is to map to identities. If you say want to use an external identity, you can go ahead and pull that external identity into Vault and then map that to an identity within Vault. And then what we can do is we can just template it in, and you can be sure that each team has sort of the same paths available to them, which makes your life easier as an admin. But then I also know that I'm not going to be able to hit this secret with the wildcard, because if I do the secret / destroy there with like a create or an update, yeah, you end up with no secret. So make it explicit, but also limit what you're doing in terms of your operations. So just read, list, separate out those read. Worst case scenario, you can link in those policies together, and you can stack them. So if you really need to have everything, stack them, but then segregate them out. Another thing that I became aware of was really knowing how are you acquiring trust. So instead of just saying carte blanche, let's give everything, or everything can, connect to Vault and do whatever it wants to, really sit down and kind of map out your data. How does your subject acquire its identity? And how does your object know that your subject can acquire that identity? It's easy to say, nah, it's fine. But this also helps you should things start getting a little bit more complex and you need to map out a little bit more of your data and know where that data flow is going. Another one I would say is, pull information, don't push your information. So if I have a client who's requesting access to Vault or wants to configure to Vault, let it request that because you want to automate that, but then let the burden of that work remain on your server side. It's a lot easier to spoof if I'm coming at you from the client side. The client can say, hey, look, I'm who I say I am, and you can believe me. And if the server is just going to blindly say, yeah, okay, it defeats that purpose of zero trust. So, what you can do, say if you're trying to configure an authorization for Vault, I would say let the client ask, say, yeah, I want to configure, and let Vault say, okay, yeah, that's fine. But then I'm going to do the work. I'm going to reach into where I need to go within my namespace, and I'm going to just configure it for you. Because that gives you some control over knowing where you need to go and where that cluster lies or that application lies for the configuration within Vault. And then once that's all set up, everything should go ahead and move freely. It also helps a little bit with controlling your traffic. So you aren't going to overload it. You know that your response the server response is to go and get something, instead of something just trying to constantly push it in, which could leave you with a DOS situation. But probably one of the most important things for me in terms of Vault is knowing that it's not a linear journey. It's not, you're going to set up Vault and the next day you're going to have this huge secrets management program that's just up and running and everybody's going to be using dynamic secrets and it's all going to be great. The reality is most companies and most banks aren't quite ready for this dynamic situation from day one. So really just work on rolling that out, but know that your landscape is also going to change. The more people adopt this cloud sort of mindset and mentality, the more they're going to understand that they need to change some things on their end. So this configuration, it ends up being a little bit more of a dance. So don't get discouraged if you get everything set up and then you feel like you're taking 2 steps back when you need to implement something else or change, the Vault platform itself. And to that end, I do think that the HashiCorp Cloud probably does alleviate a little bit of that if you're willing to give up some of that control and move into that. So yeah, I realized I forgot to put the closing slide in, but.
Perfect. Thank you, Sarah. One question did come in if you're open to answering a question.
I will do my best.
Okay, so it says, do you perform the same level of assurance against infrastructure as code as you do with software code?
Yes. So currently what we're working with is really this container platform. So we've built our own managed container platform and we work quite closely with them. So we work a lot more, it depends on where you consider containers to land, if they land as infrastructure for you or if they land more towards applications.
Perfect. Thank you, Sarah. So now we'll go into the Q&A between Guy and Dave. So I'll turn it over to you both.
Thanks, Brianna. All right. Hey, Dave.
Hey, morning.
I have a few questions here for you. I'm going to just go with them one by one. First question, what are the biggest challenges you see fintech dealing with today? Which of these specific challenges is HashiCorp trying to solve?
So, we can certainly comment on the patterns that we see at the infrastructure layer. Obviously each financial institution is doing something different, broadly speaking. The primary challenge is delivering net new applications to, digitally transform their businesses is candidly the catchphrase for everything. I think at the infrastructure layer, I was actually just saw that question. So I can maybe just share my screen and share a picture that I'm actually using for an event that we're doing in Korea later on this week. I think when we talk about the infrastructure challenge, the truth is everybody's infrastructure sort of looks the same, regardless of what industry you're in. And when we talk about the cloud model for infrastructure, and you sort of unlocking the cloud operating model, the 3 broad categories of things that people are trying to solve are, really the 3 things highlighted here, which is first and foremost, how do I take this idea of on the cloud model that I'm doing infrastructure provisioning in an automated manner, as someone just asked around the attestation of code during the provisioning process, just sort of highlights, problem number 1 people are trying to solve is how do I just sort of move my organization to this more automated way of provisioning infrastructure. And that is a construct that began on cloud, but has actually made its way on-prem more generally to people's infrastructure, which is why this is sort of an operating model rather than a destination. That's about the ability to use infrastructure as code on anything. You may or may not have seen the announcement we made with Cisco last week or a couple of weeks ago, where Cisco is now reselling Terraform Cloud. And I think it speaks to that reality that Terraform is no longer just being used to provision compute resources on cloud. It's also being used to configure networking gear and firewalls and everything in between. So like problem number 1 people are trying to solve, I think broadly speaking, is this provisioning automation problem. Problem number 2 they're trying to solve is wait a second, this idea of zero trust, again, born in cloud, because that's sort of the implicit assumption of cloud is you have zero trust, as Guy highlighted. How do I sort of institute that model across my organization? And it's in the financial sector in particular, this one is super, super close to the fore. There is no magic bullet you can buy. There's no app you can buy to achieve zero trust. As Guy highlighted, it's more of a defense in depth notion of, let me think about, asserting identity of everything that talks to everything else. How do I then, do sort of credentials management, just in time? Then how do I encrypt transactions between everything, regardless of which identity provider I'm using? So that core construct of zero trust is the second one people are trying to solve. And then the third scenario, it's sort of orthogonal, but it's related, which is, how do I unlock that DevOpsy process of application delivery? So, great that I can do zero trust, but can I do it in a way that as the folks from ABN AMRO shared, how do you do that in a way that doesn't slow developers down? I think modern applications like Zoom or one that struck me, actually, I worked at GitHub for a while, and we would deploy GitHub, the app, 12 times a day. Imagine doing that, right? Because that's what these cloud native companies do, and that's how they're able to iterate on their application development while still being secure. Well, it turns out the way that GitHub and others do that is using Terraform, Vault, and Consul. That is just sort of the basis for it. So those are the three sort of core scenarios, are the ones highlighted there. And the blueprint to unlock it, by and large, is people sort of externalize Terraform, Vault, and Consul or their equivalents as external things to allow these three scenarios to be achieved. So hopefully that scenario-based view sort of makes sense.
Cool. Thanks. All right, I'll move to the next question. How do you see HashiCorp's ecosystem enabling the public cloud journey in a zero-touch, zero-trust manner?
Well, I think your slides sort of talk through this, and we can go back to them. I think you have the core picture there. It's the idea. In fact, I'll maybe just again share a picture, because I thought Armand did a great job of describing in a tweet the principle of zero trust, which is, this is a messy view, but you sort of get the point. If you say, hey, there is no single bullet solution to the idea of zero trust, there are really a few principles. Number one is, outside of this, let's use infrastructure as code to nuke and pave our infrastructure on a regular basis. We have FSI customers that do that with portions of their fleet. They'll use Terraform to destroy and recreate the entire infrastructure every 21 days, right? That's defense in depth. That's how you make sure nothing's lurking there. That's sort of on the provisioning side. On the zero trust side, yeah, I mean, it is the idea of authentication using identity, irrespective of which identity type you have, because you're going to have multiple. Let me authenticate all machine-to-machine connectivity using identity. Let me authenticate all human-to-machine identity using boundary. And then how do I encrypt all traffic between machines in a way that I can get this sort of defense in depth model? So, that's our view of the broad ecosystem. We support any variety of identity systems. There are only 10 or 12 in the world that matter. They're all integrated deeply into Vault already, and that's the basis of how we use Vault to broker identity. So, this is our view of how you could do it. There are 4 parts to the problem. Plug and play. If you choose to use a different technology to achieve maybe the machine-to-machine access problem or the human-to-machine access problem, no problem at all. Our mission and our view is that we will have a singular portfolio to allow you to do this in a consistent, consolidated way. And I would argue that for most of the banks today, or certainly many of them, we are already playing that role with Vault and Consul, and Boundary, as Guy talked about, is something that we've seen more interest than we can accommodate. Not surprisingly, because everybody has that problem.
Yeah, and I think the zero touch part is very interesting, right? I kind of touched a little bit on it. I really think it's a game changer, the way we kind of focus on zero trust and talk about the 4 areas. But if you overlay the infrastructure and the fact that Consul now talks with Terraform to provide the zero touch, grow and shrink and react to failures in a zero trust environment, it's really going to be a game changer.
Yeah, maybe just to talk about that one for a second, because we didn't touch on that one. But what guys are referring to is sort of the, if I go back to this scenario, right? I'll maybe just use the same picture here. So this idea here obviously is about using Terraform as the way to automate things. What the slightly more advanced use case is the linkage between console and Terraform, and we're happy to talk more about that, which is, the problem today is when I provision new infrastructure to underlie my apps, say I'm using Zoom, say I'm running the infrastructure for Zoom and Zoom comes under load and I have to provision another 10,000 compute nodes for my Zoom infrastructure, who's going to update the networking rules for that? Well, it turns out the long pole is ultimately how to update the networking rules. If you're entirely a cloud native approach, you're using service-based networking with something like Console. But if you're a more heterogeneous organization, your networking gear may be running on Cisco ACI or something similar, or Palo Alto Networks. So what we did in partnership with the networking vendors, we introduced a small piece of tech called the Console Terraform Sync, which says if you provision your infrastructure if you configure your networking gear using a Terraform template, how can Console just be set up to listen for changes to that infrastructure and then auto prompt you to say, oh, more infrastructure is being deployed. Would you like to dynamically update that networking configuration given what's now out there? And that's called the Console Terraform Sync. We actually launched that last October, give or take. And it was in partnership with Cisco, Juniper, F5, Palo Alto, all the core networking vendors who support that out of the box. So if you're using any of those networking providers as part of your stack, I'd highly encourage you to take a look, because that's a way that you can do this in a very zero-touch way. Really, just listen for a subscription to a change in the configuration of your infrastructure, and then auto prompt you to dynamically update the networking gear, in minutes, not the 2 or 3 days that it usually takes folks.
Yeah.
I'll maybe drop that into the chat, actually, because people may not have seen it. It is super interesting. It's actually one of my favorite features we've ever done. But I'll drop the link into the chat so folks can see it.
Okay, thank you. So the next question, for human interactive organizations, do you think there is a way to move away entirely from username, password, credentials? And if so, how?
I think the answer is, my answer would be no, unless you have a different point of view, Guy.
It's kind of a yes/no question. I think, part of the talk we go over Boundary and how it manages the workflow in a modern way, leveraging Vault for the ephemeral on-demand creation of credentials for human. So I think this is absolutely possible, and the future of using Boundary, right?
Yeah. So that would be our view. So dropping the link in is yes. Boundary is our view on that. Yes. So it's it's still using username and password, but at the entry point, not all the way along.
Yeah. All right. Sorry. Next question. With the release of HCP Vault, how do you see the financial services industry consuming this platform?
Now, that was wild. I saw the poll questions, and the vast majority of people indicated, if they understood the question correctly, that they would be open to running Vault as a managed service from us, which to a certain degree is probably not surprising. But if you'd asked me 2 years ago, that is surprising. I think the idea behind HCP Vault, or I'll actually step back a little bit and say, hey, we've observed that most cloud programs in the world, generally set up a central shared service around Terraform, Vault, Console, and then they have multiple application platforms on top. And as ABN AMRO described, they have their custom Kubernetes platform they run. But I think most people have multiple types, right? Like Kubernetes for the new applications, container-based, but you still are trying to support your Java-based web, app server-based apps there, and there's serverless apps, and there's going to be edge apps. The common infrastructure paradigm underneath is the fact that that's now running outside of your data center, and so you need to think about ops security and networking differently, irrespective of what the application type is. So again, most people then run a shared service of Terraform, Vault, and Console, and then have multiple application platforms on top as a result. What we observed years ago was that every account we went to, every company we spoke to, that was essentially their stack. Like even people like GitHub, as I described, or even Zoom themselves, who are running Zoom, who we're using right now, like that's by and large what their infrastructure looks like, right? And so we said, well, is there appetite among the world for us to run that as a managed service, or those things independently as a managed service from us? And so we created the HashiCorp Cloud platform with the vision of being able to run any or all of those products on top. So you come to us, we can run Vault for you, we can run Console for you, we can run Nomad for you, we can run Packer for you, whatever the things might be. And we can run them on Amazon or on Azure or on Google, and you sort of get to pick. And so I think just candidly, most FSIs I've spoken to want to run Vault themselves when they run it as a central shared service, just because of the criticality of that. But departmental use cases, not so much. For dev use cases, certainly not, right? So I think that's what we'll start to see. I think my gut supposition still is that for some period of time, the central core runtime path HCP Vault service for most of the banks is going to be run by their own teams. If they so chose to let us run those for them, we think we can probably do that as effectively as they can, but I understand the risk appetite of people is different. And then more for the departmental use cases, specific app teams or dev teams that are building applications, there's no reason you shouldn't use HCP Vault, because all we do is we spin up a dedicated instance for you, give you an endpoint to engage with, and we keep the infrastructure up and running. You manage the keys. So in all intents and purposes, it's just an endpoint for you to use. But that's probably the likely scenario, which is you probably run your own for the central shared service, and then HCP Vault for everything else. But I'm open to be amazed. I mean, I think we're all amazed at I think we had close to 1,000 companies participate in our beta program, just to give a sense for it. And I would say maybe 5 to 8% of those were sort of global 1,000 organizations, which tells us maybe we'll be surprised. And by the way, that product announcement actually just went generally available this morning. So for anybody that's interested, we'll start watching what you do.
Yeah. Okay. Thank you. Next question. This is not my question. It's not a plug. What is the benefit of leveraging Boundary, Console, and Vault together in an architecture?
Yeah, I think you answered that one. I think you answered that one in terms of that's sort of what it takes to run a zero trust environment, plus Terraform for the nuking and paving. But I think we're eyes wide open. We've always been philosophically very pragmatic about how this stuff happens. We know most people will adopt that one product at a time, because you're trying to solve one product at a time, get success, and move on, rather than have a massive ocean boiling project to solve this problem out of the gate. So we think about building a single platform in a common vision, which is all those pieces being used together, but we build for the single product adoption use case. I think that's the other real pragmatic element of what makes HashiCorp HashiCorp. It's sort of this Unix view of the world. Let's solve one problem well, and we're repeating that with Boundary. You could have argued, hey, shouldn't this people to machine problem domain being solved just as a use case of Vault? Why do you need a new product for that? Well, I think it speaks to our philosophy, which is you could, but actually let's do it properly, make it a small singular tool that you use. Yes, common ACL, common audit logging, and all the other things. Of course, that's what you get, but they're going to be doing different things. So, our view is, yes, that's how you solve zero trust all up, but we allow you to get there one spoke at a time. And most people start with Console, actually, believe it or not, and then Vault second. The reason being that Console provides this global registry as to where everything is that you just sort of need as the basis of your cloud program. And then Vault allows you to then authenticate those things in whatever mechanism you so choose. But that's the order that we often see it adopted.
Yeah, that's actually a good segue to the next question. That is, when shifting from a ticket-based to self-service, what methods do you suggest to overcome the hurdles of implementation and adopting the model across cloud automation?
Yeah, we've seen people stub their toes many times on this one, and the only solution is pick a coalition of the willing. is maybe the right way to start. Is the shift from ITIL to self-service is something that is sort of unavoidable given the pressure on application teams to deliver new applications. But you sort of have to pick like one business group at a time. If you try and force that across the organization, there's just too much institutional gravity that gets in your way. Where we've seen it be really successful is, create a cloud program office, make the foundational investment in tech that says, got it. This is what's going to be required to unlock this ITIL to self-service motion. Let's find some partners in one business group, one application team, prove success, and then sort of knock them down as you go, rather than trying to force everybody into your singular funnel out of the gate. And that's just a human dynamic, not a technical one.
Yeah. All right, cool. So this question is a little bit with a forward-looking, right? So what does achieving full innovation in financial services, or generally speaking, looks like? Or what are some trends you see ramping up in the future as the industry evolves?
In terms of innovation in the financial sector? Yeah, I'll try to stay out of my predictions of sort of where things are going. I do think because every institution is unique. The simple pattern, again, this is what makes our job so interesting, is the patterns are the same, regardless of what industry you're in. It is the fundamental problem, and in this COVID dislocation has proved to all of us, is how do I enable my organization to ultimately be able to deliver net new applications to engage their customers, partners, employees more rapidly, because that is just the way of the world. And so the sort of the sprint that is on is, how do I get my organization teed up to remove the friction for that? And I think that's, at a tech level, that bifurcates into two different categories. One is, how do I create a common application delivery process coming out of GitHub, artifact scanning, library scanning, all the rest, putting that into a registry of sorts, whether that's Artifactory or whatever it might be. Then so that's the developer side of it. And turns out, maybe I'll have a few different pipelines. One of the big companies we actually spoke to shared that they have 300 distinct pipelines in their organization, which just speaks to the challenge. You cannot get people to standardize on that because different development teams have different affinities to tool chains. But then you're now delivering those net new applications into this new world of cloud, whether you like it or not. So that's how the problem breaks down in terms of how people work, where people get stuck is, hey, I'm trying to solve two things. One is, how do I standardize the delivery process? Number two is, how do I have a common logical infrastructure to deploy it to, so that my ops, security, and networking teams are not getting in the way of slowing everything down in service of this digital transformation push. Obviously, you use GitHub or whatever it might be on the left-hand side, and then you would use, the cloud providers on the right-hand side. 99 times out of 100, most big companies go, I have to externalize the core aspects of ops, security, and networking, so that regardless of what type of application's coming, and regardless of which cloud it's going on to, I'm using a common security model or common networking model. And that's, GitHub actually created this really cool graphic, which is sort of like the DevOps workflow with GitHub on the left, HashiCorp on the right. I think that actually speaks to the kind of the market truth. So maybe not the question direction that you're asking directly around the business cases, because I can't comment on those, but I do think at the infrastructure layer, those are the two patterns: dev side, ops side, GitHub, HashiCorp plus the cloud bits. And that's actually in harmony with the cloud platforms, candidly, because HashiCorp reduces the friction for Amazon, running your workloads, which is ultimately where they make their money. They're not in the business of trying to sell you tooling.
Yeah. Right, great. Thank you, Dave. I think